Hey guys, today we're going to do an introductory lesson to sketching quadratics. And when I say sketching quadratics, that doesn't mean that it's just going to be a messy little sketch. It's actually going to be very accurate. It's just that we're not going to fill in a table of values and plot individual points the way we usually do. Let's get started and I'll show you what I mean. All right, let's get started. First of all, you should know the shape of a quadratic. Is it going to be an N shape or is it going to be a U shape? Here are some different quadratics, and I'm hoping that we already have that knowledge to begin with. Okay, so looking at these different quadratics, it's always in the format y equals some number of x squared plus some number of x plus some number. And what tells if it's going to be an N shape or a U shape is the x squared term, whether that x squared term is positive or negative. A positive quadratic, so a quadratic where the x squared term is positive like this one, will have a U shape, while as a negative quadratic, like one like this with negative in front of the x squared term, will have an N shape. You should know what the basic quadratics look like y equals x squared. That's this one here. We can plot a few points and check that this is true when x is equal to 0. Y will be equal to 0 squared, which is 0. When x is equal to 1, y will be equal to 1 squared, which is 1. When x is equal to 2, y will be equal to 2 squared, which is 4. So that's off the graph. But you see the shape I'm making here. And when we go into the negatives, it starts growing as well, because when you square a negative number, it becomes positive. So when x is negative 1 squared is positive 1. When x is negative 2, y is negative 2 squared, and negative 2 squared is positive 4. So it gets infinitely large as we go across to the right-hand side, and infinitely large when we go across to the left-hand side as well. Now, how many solutions does x squared equals 0 have? Well, looking at this graph, this is the curve where y is equal to x squared, or the solution to x squared equals 0 would be where y is equal to 0 on this graph. Now, this is my y-axis. This is where y is equal to 3, 2, 1, 0. Where y is equal to 0, we find the x-axis. So when we're asked how many solutions are there to where this quadratic is equal to 0, what we're really being asked is, how many places does this curve touch the x-axis? And in this case, it's just this once right here. Sometimes quadratics have one solution, sometimes they have two solutions, and sometimes they have no solutions. Now, what would this quadratic look like? Y equals negative x squared. That's this one here. Notice it looks very similar to the y equals x squared graph. It's just the negative of that graph. When we've got a negative x squared term, like we said before, it's got that N shape. But we could check with a couple of values. When x is equal to 0, negative of 0 squared would still be 0. When x is equal to 1, the negative of 1 squared would be negative 1. So that's this point here, and so on. So as we go across to the right, we've got a negative in front of the x squared term, it gets infinitely smaller. And as we go across to the left, again, anything squared is going to be positive, so put a negative in front of that, and they are all going to be negative, so infinitely more negative as we go to the left as well. How many solutions does this one have? Well, how many times does this curve touch the x-axis? Again, it just touches the x-axis once right here. So there's one solution. Now what about this graph? Y equals x squared plus 1. In order to graph this one, you might want to use a table of values to be really clear of the different y values that go with the different x values. So filling this in, I've just got some values for x here, and it's not enough just to have 3 numbers because of course we're drawing a curve, not a straight line. So you need to have a really good idea of where that curve is going to bend and the steepness of the gradient. Okay, so when x is equal to negative 3, we're going to do negative 3 squared. Remember, that's going to make it positive. That's going to be 9 plus 1, which is 10. Negative 2 squared will be positive 4 plus 1 is 5. Negative 1 squared is 1 plus 1 is 2. 0 squared is 0 plus 1, which is 1. And 1 squared is going to be 1 plus 1 is 2. 2 squared is 4 plus 1 is 5. So I've just substituted all these x values into this equation to find the y values that go along with them. Now I've got coordinates that I can plot and graph. Or I might have just noticed that this equation here looks very similar to this equation here, y equals x squared. The only difference is each of the coordinates is just one higher than on the y equals x squared graph. So the y value is one more than it is in this graph. And look at this one. This is where y is equal to x squared. Negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1, and so on. And notice that all of the numbers in this table are just one higher than the numbers in that table. So if we know what this graph looks like, which we definitely should, we should be able to see what this graph will look like without having to plot every single point. So here's my graph of y equals x squared. The graph of y equals x squared plus 1 will just be one higher than that. And how many solutions does this one have? Well, y equals x squared had that one solution, if you remember, down here where it touches the x-axis. So y equals x squared plus 1, that's all been lifted up one square. And you'll see that there are no solutions. It doesn't touch the x-axis at all. Y equals x squared minus 3. What's that going to look like? Again, we fill in a table of values. So where x is equal to negative 3 squared is 9 minus 3, that's 6. Negative 2 squared is 4 minus 3 is 1. Negative 1 squared is 1 minus 3 is negative 2. 0 squared is 0 minus 3 is negative 3. 1 squared is 1 minus 3 is negative 2. And 2 squared is 4 minus 3 is 1. So I filled in my table of values and I could plot those exact coordinates, which will give me an exact idea of what this graph looks like. Or once again, we could say, I know what this graph looks like because it looks very similar to the y equals x squared graph. Each coordinate is just 3 lower than on the y equals x squared graph. So here are the coordinates for the y equals x squared graph. This is just negative 3 squared, that's negative 2 squared, negative 1 squared, and so on. And notice that all of the values in this table of values, my y values are just 3 less than this one. Okay, so you should be able to see that on the graph. If you know what this graph looks like, y equals x squared, you should know that this graph is just 3 lower. All of the y values are 3 lower. So here's my y equals x squared graph, and there's my y equals x squared minus 3. Remember, my y equals x squared graph just touches the x-axis at this one point here, while the y equals x squared minus 3 graph 3 below the x-axis, so it's not touching the x-axis here, but it is crossing the x-axis in these two places. So how many solutions does it have now? It's got these two solutions, although we can't see exactly what they are. Now, another word for solutions to a quadratic when it's equal to 0 is called its roots, where it touches the ground, you could say. Now here comes the practice. For each of these quadratics, start with either a graph of y equals x squared or a graph of y equals minus x squared. Now these should be accurate graphs, like these. Each of these points are plotted accurately. The reason we're doing that is so that you can show the similarities between these basic parabolas with the quadratics I'm asking you to sketch. So note the similarities between this graph and this graph. Start with this graph and sketch this one. Do that for each of these. Go ahead and hit pause, and the answers will come up in just a minute. Here come the answers. So for y equals x squared plus 2, you should notice that each of the coordinates are just translated. That's moved directly upwards 2 units. The blue graph is my original y equals x squared graph, and notice this point was moved up 2 units. This point over here, the point 1, 1, was moved up 2 units to the point 1, 3, and so on. All of these points have been translated up 2 squares. For this graph, you should see a similar translation, but all of your y coordinates will have been translated down 1 unit. So originally I had this blue parabola, and the green parabola just shows that each of the coordinates were translated 1 unit down. So this point over here was also translated 1 unit down. This point over here, which was the point 2, 4, was translated down 1 unit to 2, 3. All of the coordinates were translated 1 down. Similarly, the curve y equals x squared minus 5 will be translated down 5 squares. All of the y coordinates have been moved down 5 units. Here's my original y equals x squared curve, and this is my new y equals x minus 5 curve. See, this point has been translated 5 squares down. This next point over here, which was the point 1, 1, is now translated down to the point 1, negative 4, and so on. This next graph is an interesting one because it starts with a minus x squared. So you should have started with the y equals negative x squared graph. And you should notice that this graph that we're sketching here is translated 3 units up from that graph. So the blue graph here is the graph y equals minus x squared. And you notice the green graph here is the same as the blue graph, except each of the coordinates were plotted 3 higher. This one may have confused you, but notice that there's a negative x squared term here. So this is a y equals negative x squared, which has been translated up 7 squares. This is a positive 7, so we're adding 7 to the graph of y equals negative x squared. There's my original y equals negative x squared, and you see the green curve is 7 units above each of the coordinates on the blue curve. And this last one, different from all the rest, I'm not just translating this time, that is, I'm not just moving all of the points up or down. This time I am stretching this curve. All of the y values are 2 times what they were previously, so the curve is being vertically stretched by a scale factor of 2. Notice the point 0, 0 multiplied by 2 is still going to be at 0, but all of the other y coordinates on this blue curve have been multiplied by 2. So the point 1, 1 becomes the point 1, 2. The point 2, 4 becomes the point 2, and 4 times 2 is 8, all the way up to 8 there. Okay, so all of the y coordinates have been stretched vertically by a scale factor of 2. Please send me a message if you had any problems. Otherwise, if you're feeling comfortable with this, we should be ready to move on to our next lesson. Look for the video on Sketching Quadratics Part 2. Remember, this was just an introductory lesson. There are still quite a few things I need to tell you to ensure that you're going to get full marks on these questions. See you next time.